Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm Peter Ballant from Technicon, and today we look at the SERENA project. This is a European project which has an important role in leveraging sensing and telecommunication networks of tomorrow. We all know that 5G is coming and has even arrived in some areas, but what most people do not know is that for us to take advantage of these super fast data transfer speeds, new infrastructures must be developed. This includes new antennas, and this is where the SERENA project comes in. Partners are looking at using gallium nitride alongside silicon to enable beam steering antennas. Their goal is to develop an architecture which is small, cost-efficient, with robust thermal management schemes. And to tell us a little bit more about SERENA, we say hello to Uwe Maaß. He joins us from Fraunhofer in Berlin. Fraunhofer is one of 9 project partners across Europe. Welcome, and thanks for agreeing to talk with us today.
Thank you for giving us the opportunity to present a little bit about the SERENA project. I guess for us as a research organization, it's also interesting to try to explain what we are doing to the outside world. And I think podcasts are quite suitable. You have a bit more time to discuss options. And I think it's a good option. Thanks.
Well, Uwe, you just hit the nail right on the head when you said we like to explain what we're doing to the outside world. Many times in these EU technology projects, this is a little bit difficult. And since our listeners basically run the gamut of everyday citizens all the way to perhaps scientific people, how would you describe SERENA?
From our point of view, we would say SERENA is one of the projects for realization of what is now known as the 5G mobile networks. So I guess most of the people know that we have wireless networks with different technologies. So many will recognize 3G networks, 4G or LTE networks. So some of the vocabulary that was mentioned describing the technology that is used. And it basically incorporated that you had, I would call it maybe better transmission with mobile phones, especially faster transmission. It allowed for data transmission along with actually telephone calls. And now this 5G network introduces even better performance for this data transmission. And the goal is to increase the bandwidth so that people on the street or people using 5G networks will experience higher data rates, less waiting time, less latency for connections, so that they more or less experience like maybe an internet connection they would have if they're sitting at their computer at home. So this will be higher communication bandwidth, I think, lower latency as mentioned. In addition, the idea is not only to have like mobile phone communication between actual people, but also to open the network to wireless sensors, for example, wireless machines that generate data, measure environmental data like temperatures, like any parameters that can occur in a manufacturing environment, for example, in some kind of machine there, and provide this data to some kind of control computer so that it can better be controlled, the manufacturing processes, and then be used to optimize, for example, energy consumption or material supply.
Okay, so it's improving our network that we have come to rely on so much and sort of get it ready for whatever the next generation is, which it will be data intensive. We know this for sure.
Yeah.
Okay. And that you mentioned, and I also saw this on the website for SERENA, active millimeter wave arrays. First of all, is 5G millimeter wave technology?
So that's a good question. Millimeter wave technology actually means that we use a certain frequency spectrum for the transmission of the information we have that is higher than what is currently being used. And that's one of the technologies that's actually being applied to improve the mobile networks. 5G is not only millimeter wave technology, but it also incorporates further research and development and signal processing, and also a bit the structure of wireless communication infrastructure in the cities, I guess, how this will be set up. All of this will then be used to increase the performance of the 5G networks.
Uwe, we talked about the improvements to the network speeds that we're trying to accomplish with SERENA. What would be a use case, or what is the product that we need to supply this network for? Can you imagine a particular item that we will need that has such a intensive data speed requirement?
Mm-hmm. So I guess most people who use mobile phones at some point have wished for higher data speeds or more reliable internet connections while they were out on the streets and trying to assess like some kind of video stream, for example, from something, or trying to find some information somewhere in a city where they were not necessarily familiar with the city. That especially for high data rate intensive applications. So for example, video streaming, I could imagine would be one of the applications. But also if you think about new forms or new technologies for actually visualizing data or interacting with electronics, like virtual reality, for example. So if you think about games, for example, but also in the workplace environment, if you have large data sets of, energy transmission from renewable energies to different people requiring energy, and how to actually display this kind of large data sets, I think this could benefit also from virtual reality. Also, there's the idea of augmented reality. For example, if you think about you go to like a museum or doing some kind of visit of a town, and then you have like a virtual reality glasses, and then you're looking at a certain picture, for example, or you're looking at a certain building, and the technology can then be used to identify the building and just transmit information in parallel while looking at it, so that you get more information also from the building. So I think there are many applications, both in the for private usage, but also for industrial usage. And I could envisage that in the future, that will also lead to changes on how we use, for example, our computers, be more efficient.
So is this a market-driven project, or is it a technology-driven project?
So I guess it's a bit of both. In the past, I guess you often had the case that there were new technology developments which lead to new possible applications, and then there was somebody else who picked up this development and then used it for some, high data transmission. But I think in the meantime, we have come to expect so high internet quality that I could imagine that there is actually a need for high data rate connection, mobile wireless connection. And also, I think that especially in the industrial environment, so workplace environment, that incorporating more information from the manufacturing processes to these wireless sensors gives new opportunities for manufacturing.
Which makes SERENA a really important project, because you're sort of paving the way for what happens in the future, which is an important task, of course. And as I read a little bit about SERENA, I see that a key part of the project is incorporating gallium nitride, or GaN, which is a semiconductor material. And this is a material that you're using or you're researching in SERENA. Is this in an effort to replace silicon, or are you looking to build some sort of hybrid model using the tried and true silicon and gallium nitride?
Actually, it's the second part. As you mentioned, there are different semiconductor technologies available. So gallium nitride, silicon, I don't know, lots of other special application technologies for different applications. And each of them has their own advantage. For example, if you look at the silicon technology, which is mostly being used today for high volume applications like PC processors, also the most of the processors in smartphones, and also the memory is being used or is being manufactured in silicon technology. So this has the advantage they can manufacture very small structures, and they go for very high quantities, so very high numbers of devices they build from one manufacturing run. So this is then a very efficient way of manufacturing. So you get basically per manufacturing run a lot of devices, and this reduces the cost. On the other hand, research that has been done in silicon technology has led to the fact that you can also apply it now for some of the RF applications, so that you can basically combine digital signal analysis, digital processing, like it's being done on a computer, for example, with some kind of the data or signal generation you need for wireless data transmission. But what silicon is not so good in, at least currently at the moment, is producing high output power. So basically, if you want to transmit a signal from, say, from a mobile wireless base station to a consumer who is having a mobile phone, you need a certain amount of electrical power, of RF power, to achieve a certain range, transmission range. And this output power cannot be produced so efficiently in silicon technology. This can much better be done using gallium nitride technology. So what the approach of the SERENA project is then that we try to combine the best parts that are available for the different technology blocks that are required within this module. The silicon for the digital part, and also for some of the RF signal generation, and then the gallium nitride for generating the high output power, and combining this into one module using this packaging technology that we develop here at Fraunhofer IZM to have a module which can then be used for this millimeter wave technology.
Okay, and does gallium nitride kind of look like the best candidate for doing this job?
I think gallium nitride is actually quite usable in this case. It provides high output power, much higher than what can be achieved with silicon. So I think in this respect, it's the best candidate, I would say.
And one of the key applications of the technology that you develop with SERENA is for millimeter wave radio base stations. Can you describe these stations and tell us how they'll be used?
If you think about such a wireless or mobile system, the way it works, that you have basically this base station, which provides the data or the calls and transmit them wirelessly to the end user, so to the people on the street who have the mobile phones, or to any device that has a wireless connection. So the base station basically takes the data that is coming from the wired internet. So you have some internet server somewhere, or you have a caller that has a landline, and then he wants to connect to somebody with a mobile phone. And then the signal is being transformed into a wireless signal inside the base station. It's been amplified, and then the base station has to decide in which direction it has to send the signal. So where in relation to the base station is the end user located. And then it actually sends the data, the information wirelessly to the user.
Is this what we call beam steering?
Exactly. So one of the technology that can be used here is beam steering. Especially if you go for high frequencies, you have quite high losses of this power that we talked about between the actual beam steering and the end user. And in order to overcome this, you can try to concentrate the output power in a certain direction, so in a certain beam, so that you do not send over in a wide area, but just direct the power to the end user that is actually requiring the information. And therefore, you can better overcome the high losses at the high frequencies.
Ah, okay. So it's a way of really just aiming this signal right at or as much as possible to the end user.
I think that would be the role of the Fraunhofer in the project. Yeah.
You're from Fraunhofer in Germany, and they are project partners in SERENA. Tell me, what is the role of Fraunhofer in this project?
So Fraunhofer is a research organization, and it's actually doing applied research in many different areas. And they have lots of institutes, where each institute basically has its own research field, research area, we'll call it. So for the IZM, where we are working, so Carmen and I, and also the colleagues that are doing the technology, we are focusing on electronic system design and electronic packaging. So that is basically technologies to build electronic modules and the assessment of these technologies and developing of the production processes, as well as the electrical and thermal design. So if you consider that's a very compact model, we know if we have some electrical device, oftentimes they get warm or hot during the operation. You have to take care that the heat that is being generated has to be taken care of. And also, if you think about RF design, that's often a bit difficult because generating RF power is only possible with a certain efficiency. And oftentimes you generate some losses. And therefore, you have to take care that the RF power you generate does not get lost in the transmission inside the module. So that's where you have to take into account in the design of the module.
Fraunhofer is one of 9 partners, actually, from 5 different countries. So at some point in the project, you have to come together as a team. And with our current COVID situation, this is probably a lot more difficult to do. But this kind of research project that involves a lot of different people in remote locations could sometimes have challenges. Can you cite any particular challenges within SERENA?
You mentioned, of course, like an organizational challenge. We were a bit surprised, of course, like everybody else, with this occurrence of this COVID-19 situation. I think as it was like a project with partners distributed all over Europe, we, in the beginning, before the COVID, the project already started sometime before, we already relied on telephone conferences and video conferences. And this, of course, was used more during the situation. So from a technological point of view, the difficulties were actually in the question how to realize such a module. So it was development of the actual technology that was used. We had to apply new materials that are suitable for the RF integration of all of these functionalities. And then we had to make sure that the RF design of the actual package, so of the antennas that are being used, but also of the signal transmission lines inside the packages, meet the specifications that are there for the signal transmission inside the package, but also the power supply, so what is sometimes also being called as power integrity. So if you supply some kind of voltage, some kind of power, output power, it has to make sure that all of the components inside the packet actually have the power in a certain quality as it is required from the devices. All of this together, all with the manufacturing, actually makes it a quite challenging project for Fraunhofer, but also a quite interesting project.
Are you actually building something? Is there a demonstrator that you can actually show at the end of the project?
Yeah, so exactly. So it was agreed that all of the research outcomes that are being done by the partners will be assessed more or less or validated using a demonstrator, so that all of the individual developments go inside this demonstrator. And as the demonstrator, it was used is that we built such a base station system for wireless data transmission, and then try to have a high-speed data transmission using our system.
Okay, and is this system already built, or is this yet to come? Because I think the project ends, at the end of this year?
Yeah, it was extended. So actually we are in the phase of building the modules. All of designs are ongoing. So we're more or less in the hot phase of the project, and we expect the results by the end of the year.
Oh, and this must be really fulfilling when you finally could build something to prove your theories.
Actually, that's true. So most of the work is nowadays being done on a computer. So in terms of the design and the analysis of the devices, of the module you have, and once you can really build these things and you have them directly before you, so oftentimes it's surprising how small the devices actually are, because if you're working on it on a computer, you always have it on the size of the computer screen, of course. And then you get reminded, okay, it's actually a small device. And of course, it's nice to see then the measurement results and to see if it is working, if there is maybe a problem that you did not think of before, and where you have a real learning effect then in the analysis of the data. That's actually quite an interesting part.
Yeah, and actually this is the value, I suppose, of actually building something at the end, is that you can test what's been theoretical up to that point.
Yeah, I agree. Yeah. So that's actually basically, so mostly in engineering, it's very important to have measurements as the systems become more and more complex. And it's sometimes difficult to predict everything in simulation. So it's always good to have a real working demonstrator or system where you can do tests and then study the actual performance of the devices.
This is an exciting project with a really big impact for our community at large. For the person on the streets, this means they will be able to continue to work wirelessly in a much quicker fashion and perhaps be exposed to a lot of new different technologies, like we said, virtual reality, augmented reality. It's a cool project. It's required a lot of work up to this point, and it will be done soon. But for all of your work that you've done so far, I say thank you, and especially thank you for taking the time to share with us what you've done and some of the challenges and some of the results up to this point. So thanks for sharing with us today.
Yeah, thank you, Peter, for taking the time. Thank you.
For more information about SERENA, visit serena-h2020.eu. This podcast has been brought to you by Technikon. This project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 779305.